going to do problems 1 through 5 on review day number 9. First one here is the limit as x approaches negative infinity of this right here. So what you have to do is really understand what it means to have have its exponent go to negative infinity. So just kind of off to the side, I'm going to write 2 to the negative infinity. The negative, again, flips this over, so it's 1 over 2 to the infinite power. So this is going to get super, super big. And as it gets super big, 1 over it is going to go to 0. So 2 to the negative infinity, that part goes to 0. And 5 to the negative infinity, for the same reason, goes to 0. So really what happens is we get 3 over 4, 3/4, that's C. So it ends up being, it's hard, it's a little strange at first, but ends up being a pretty easy problem from there. Second one gives us a differential equation and shows us some steps that a person took and asks us where did the mistake happen. So the first thing they should have done is divided by y cubed and brought dx over, and that's exactly what they did. So step 1 is good. We'll give it a smiley face. Then they were supposed to integrate, and this is where the trick happens. You see 1 over, and we're so used to 1 over y going to natural log of y that sometimes we just take anything that looks 1 over and we put it into natural log, and that's not what's supposed to happen here. Instead, that should have been y to the negative 3, which would have gone to y to the negative 2 over negative 2. That's not what they did. This is the mistake. So step 2 is our problem there. All right. Then we get number 3, and it says what's the slope of a tangent to the graph of here at x equal 1. So we have to find the derivative and plug 1 into it. So we're going to use quotient rule. Bottom times derivative of the top. Derivative of the top will be e to the negative x times negative 1, so there'll be a negative there, minus top times derivative of the bottom, which is just 1, so it'll be that, over bottom squared. Okay, so this is our derivative, and if you did that, be encouraged. We're going to put 1 in, and that's going to give us negative 2e to the negative 1 minus e to the negative 1 over 2 squared, which is 4, which gives us negative 3e to the negative 1 over 4, and e to the negative 1 means it can flip over, so we get negative 3 over 4e, and that's option B. Okay. So again, not too bad, it's just quotient rule, plug it in. Don't get too hung up on the 1 over e until the end, I think, but that's how we do that one. Okay. Then number 4 here gives us a graph of f prime, and it says when is f increasing? So f is increasing when f prime is positive. And this is f prime, and this is positive starting at negative 1 and all the way until 3. So from negative 1 to 3, B is our option. Okay. Pretty easy one there. Then number 5 here says the rate at which water leaks from a tank in gallons per hour is given by R. So R is a rate, and they want to know what's the best interpretation for R prime. So we're taking the derivative of something that's already a rate, right? And so therefore, if we look at here, the amount of water in gallons, we would get an amount if we integrate a rate, not if we take the derivative. So that's out. The amount of change in gallons per hour in the rate is leaking during the 3 hours. So if we want the actual how much it changed, we have to integrate as well, not take the derivative. The rate at which water leaks from the tank in gallons per hour 3 hours after the tank. Now this one I could see you choosing, but that's actually what R of 3 would represent. R is the rate that it's changing, so if you put 3 into the R function, that's what C would give you. D is the rate that rate is changing in gallons per hour per hour. So D is our choice there. All right, so not too bad.